Hey guys, welcome back. Mr. Marone here with your second of 7 videos to be used with our summer packet. This one is the angles and angle pairs, so it matches with topic 2 within that packet. So we're just going to do a very quick review of angles. I know you guys have all seen angles many times over your career, but just to really kind of the detail-oriented part of it is that an angle is formed with two different rays with a common endpoint. Okay, and if you don't remember what a ray is it's a figure where it starts with two rays. A ray starts with an endpoint and continues off in one direction infinitely. And we use one label here to, sorry about that, guys. Let's get out of that. There we go. So in our ray that's given up here, we have a single endpoint, which we'll call that H, and then it's got some other point on the line which we can call J. So this will be called ray HJ. Okay, and once again, just like we did with a line, we're going to draw a mini ray over the top of it. Okay, so an angle is formed by two rays that share an endpoint. So if I had another ray drawn in that shared point H, we would have an angle. Okay, that common angle is called a vertex. It's called the vertex, and the rays are called the sides of any of our angles. And we name an angle using 3 letters. The middle letter has to be the vertex. So looking over here, they gave us angle ABC down in our example here. Okay, notice that A and C were the two letters on the rays themselves on the sides, and B, the vertex, was in the middle. It has to be written that way. If you write it BAC, you're referring to a different angle. Okay? Now, if there's only one angle located at the vertex, like we have here, you can call this angle B. If, for instance, I had a second angle drawn in here, like this, and we'll call this one ray BD, okay, if that were the case, because there are two angles, angle 1 and angle 2, at that vertex B, we could not call them angle B because there are two angle B's there. So just keep that in mind. Now, just very quickly, we've got 3 types of angles that we're going to look at. You've got acute angles, which I'm sure you guys have all seen before, and acute angles are 1 to 89 degrees. You've got obtuse angles, and obtuse angles are 91 to 179 degrees, and then you've got right angles, which are 90 degrees. And you will also sometimes see what are called straight angles, just like this. And straight angles are always 180 degrees. So there's really 4 types. 3 are the main ones, with the straight angle being just kind of a throw in for extra. Now, when it comes to angle pairs, there are 5 different types. The first one are called adjacent angles, and those are angles that share a common side. So you've got 2 examples above, angles 1 and 2, angles 3 and 4. And if I highlight it for you, you've got a shared side in each. So here's our shared side there, and there's our shared side in 3 and 4. Okay, they share a common vertex as well. So this point down here is shared, this point down here is shared. So it's very similar to what I drew on our first example. Okay, they have no common interior points. All of angle 1 is separate from all of angle 2, and same thing with 3 and 4. But if they're right next to each other, that's another way of thinking of adjacent angles, angles that are right next to each other. Okay? Then we've got what are called vertical angles. They are angles that share a common vertex, so we've got a common vertex in between here, and their sides are opposite rays, meaning they are rays that go in totally separate directions, okay, or create a straight line. So we've got angles 1 and 2 here. This is angle 1, and this is angle 2, and they share that common vertex. They're right across from each other. Same thing with 3 and 4. Here's 3, and here's 4. Okay? They share that vertex. Their sides are opposite rays, and if you notice, they create a V. That's a good way to think of vertical angles, V for vertical. Okay? Same thing with 1, 4, and 2. And vertical angles will always be congruent. So angle 3 will always equal angle 4, whatever their measures are, and same thing with angles 1 and angle 2. Okay, so vertical angles will always be congruent. Next one is the complementary angle. And these are two angles that create a right angle or an angle that measures 90 degrees. And we've got an example on the left here, angles 1 and 2. Those are known as adjacent right angles, or adjacent complementary angles, because they create a right angle. They do not have to be adjacent, so you can have examples, angle A and angle B. Those two do add up to 90 degrees, so they would be complementary, but they are non-adjacent. More often than not, you will deal with this type, with the adjacent ones, but you do need to be aware that there are such things as non-adjacent angles. We now have supplementary angles. They're very similar to complementary. They together create a straight angle or a 180 degree angle. And once again, they can either be adjacent, like you see in angles 3 and 4, or non-adjacent, as you see in angles B and C. Okay, they can work either way. And a good way to remember this is that complementary and supplementary, C comes before S in the alphabet, and 90 comes before 180 when you're counting up. So C goes with 90, and S goes with 180. And our last type that we're going to look at are called the linear pair. And this is when we have adjacent angles that form a straight angle. Okay, those would also be called adjacent supplementary angles because they do form a straight angle, so they do equal 180 degrees together. And that's where when you deal with supplementary angles that are adjacent, they really have two names. They can also be called a linear pair. So just keep that in mind, and you have examples of all of these, and these videos will be available all year for you to continually reference as you go through. So good luck on this section of the summer packet, and stay tuned for video number 3.